as we noticed, we were able to run this program and print the values in as part of separate processes, 242676 and 2477, right? 24277. Let's bring some more context into this. Let's add another statement here. I am in the main, or let's call this the starter process, like starter parent process, right? And let's put another statement here to say I am, or let's say ending the starter parent process. Okay. Now this will add some more context to it, and you'll notice something here. All right. You noticed that the main process, which is 24292, started and ended. That's interesting. And the sub-processes, which are 24293 and 24294, ran in the background and they ended, right? So let's see what happened here. Typically, when you are writing a program, you would think sequential execution, right? You would think, okay, I output this line, I do this, which starts another process. Let me execute that process. Okay, it's going to print this line as second line. Then it's going to execute the third one, which is subtract process, print this line, and then it's going to end, right, the start process. But no. Remember, we talked about this being independent processes. So while process number 24292 is running and starter processes 24293 and 24294 in the background, they spawn as independent processes running separately. That means it's kind of like I kick off these two processes and I move on. So now, what if I want to have the main process wait till these two processes are done before I can do something else, right? That's where the join statement comes. So p1 dot join. Join is a blocking code which waits for the sub-process to finish before proceeding to the next statement. So this is saying I'm going to wait for P1, I'm going to wait for P2. If they're both done, then I'm going to proceed. So let's see the difference. So this is how it was before. Just keep this in mind. I'm in the starter process. I'm ending the starter process. Okay, then it prints add process, subtract process. Fine, let's run this process. Let's run this program again. Let's see how it prints. Okay, now it's more in order. Now I'm in the starter process. I start add process, subtract process, and I end the main process. So basically this started, it waited for these two guys to finish, and then this happened, right? Okay, now is it always true that the first process that started is going to print first and the second process is going to print second? No, that depends on the amount of processing this guy has to do versus this guy has to do. This being a very simple program, it pretty much ends in very quickly, and so we don't see a difference. Let's try introducing some delay. So let's do time, and let's introduce a sleep delay in add. Let's introduce a sleep delay of 3 seconds here, and let's introduce a sleep delay of let's say 1 second here. Let's see what happens, and let's look at the order of printing now. So the expectations are, I'm in a starter process, good. I'm gonna see that this guy is taking longer, right? So this is gonna print before this happens, and then finally it will wait for those two processes to complete before the main process can print this line. Let's try this. All right, main. So as expected, after a second, it printed the difference of the subtract functions log statement. Then it printed the sum functions or add functions log statement, and finally it ended the starting process, which is right here. So as you can see, join is a blocking code that waits for these two independent processes. Again, mark the word and remember the word independent processes. Executing in its own timeline, it waits for them to finish before it can move on, right? So this is multiprocessing using functions, just functions and the process class. Now, there is another way. If you come from object-oriented background, and if that's what you prefer, there is another way to implement this same concept by using classes and inheritance. All right, let's go to that topic then. So I have another Python file here. I already have the code, so I'm just going to copy paste that. So I'm going to start with the same import statements I had here, and let's start with the logger also. Let's instantiate the logger right here. Now there is an important thing about loggers. Although in this program I have put the logging as a common logger, and I'm using this std output, but if you want to use a file handler, please look into what's called a queue handler. Do not follow or do not do multiple file handlers to the same file from multiple processes. It is going to cause several issues with multiple processes writing to the same file. So please look into queue handler. I will cover that if I find time. I will cover that in another tutorial. So coming back to this section, let's have a process here. Let's call a class called add helper. Let's call this add helper class, and let's define a function in here. I'm going to copy paste this function right here. All right, copy and paste here. So as you know, with classes, we have our first any argument in our function or method inside a class is the instance of the class itself, which is denoted by the variable self, right? Similarly, let's have a class called subtract helper. So let's call it subtract helper, and let's define the function subtract in there. So let me go here, copy paste this piece of code so you don't have to watch me type. Copy and paste. Alrighty. So that now we have created two classes. Well, can we use this in multiprocessing yet? In the method, in the way we were talking about? No, not yet. To do that, we are going to extend process. Same thing here, process. Right, the same process class that we had used here to start a process using the functions. We can do that as a class. So class add helper process add so on, right? Now, when we have a process, the way it works is we can override the init method, and you must be familiar with the init method. Again, I'm not covering all the Python basics here. The init method that is going to instantiate certain class or instance level variables here. So we are going to init, take our constructor, take a and b parameters, and we're going to give it to self.a or assign it to self.a and self.b that can be accessed from here. So I'm going to say add function will add two variables that's obviously going to log the line a plus b. Okay. Another important thing about using process class, extending a process class, is we need to override the run method. So the run method is overridden of the process class, and I'll get to where all this comes into play. The run class is overridden, and we are going to call self.add. So we're going to call the function passing in the variable self.a and self.b, right? Okay, so I'm going to do the same for this guy too. So I'm going to copy paste the constructor. I am going to add or override the run function, right? And obviously I'm not going to call subtract or add inside a subtract. I'm going to call subtract. Good. So this is how our class looks, right? So it basically extends the process class, overrides the init method, takes the argument, assigns them to the variables and then overrides the run method and calls the function inside, right? Same thing for the subtract helper. Now let's call this guy. So I'm going to copy paste again. Same idea. I'm gonna in our main process, I have this log statement. Obviously, from the main process, I'm saying P1 is. Notice the difference. P1 in the previous way of coding, we had it as a process object passing in the name of the function, or actually the target of the function. This is a name, whatever we are passing in, and then we are passing the arguments, right? And we are saying P1.start. How are we doing differently here? We are instantiating a class called addHelper with two parameters, 5 and 6, right? Those are our values, and similarly instantiating the subtract helper with values 8 and 5. So let's see what happens. 5 and 6, when you call addHelper 5 and 6, it will go to addHelper class, and it will instantiate or instantiate that object, that instance of the addHelper class, and assign those two values there. That's it. That's all what it has done so far. So basically it has instantiated an instance of the addHelper class. What does this do? Exactly the same. This is it, right? Now it hasn't started the process yet. The process hasn't started. How do we start a process? Same way, P1.start, P2.start. What happens when we call P1.start is it calls the run method of the instance, which basically internally calls the add function inside the class and passes in those two values that we had assigned as part of the constructor and executes whatever it has to execute, right? Same thing here. Run, call the subtract, print the line. Great. So that's what this does. And obviously join, as we spoke before, and print our last statement in our file or the main process. So let's execute this. Okay, my mistake. Okay, there we go. So I'm in process 24434 from the main process. So I am in the main process. I instantiated these variables. I don't have a print statement there, so I'm not printing it yet. Then I instantiated this subtract helper class. I start running them, which executes, like I said, the run function, wait for it to join, and ending the main process. So again, as you can follow, sum is 11, so 5 plus 6, 11. Subtract 5 from 8, difference is 3. And as you can see, process ID is 24435, 24436, and then coming back to the main process, which is 24434 right here, main process, and ending main process. So this is multiprocessing in Python, done in two ways. One, as a function, and second, as a class overriding the run method. I hope this helped get you at least a starting point. Thank you again, and please provide your comments. I know this is my first tutorial. I may have a lot of the uhs and ums. Sorry for all that. Thank you again. Bye-bye.